Well, well, well. Look who we have here. All right. Now, we're getting into these trigonometric identities. They're on your notes already, so you don't need to worry about that. But the first column you'll see are just the reciprocal identities. It's just like cosecant is the reciprocal of sine, secant is the reciprocal of cosine, and cotangent is the reciprocal of tangent. We already knew that. Now here's some fresh ones. You have these tan and cotangent ratio. Tan is going to be your sine over cosine, and then cotangent would just be the reciprocal of that. Cosine over sine. Now here's some wild ones. You have these Pythagorean identities. So this is when you start seeing stuff squared and like a +1 or a 1 minus, you're going to be in this Pythagorean identity column. And then these negative angle identities, if you look, if it's sine of negative theta, you just kick the negative out in front. That also goes for the reciprocal function. Cosecant, those are called odd identities. So the odd ones, you kick the negative out in front. Cosine is an even identity, so you'll see cosine of negative theta, all of a sudden the negative just vanishes. What? And that's the same for secant. If it's secant of negative theta, just get rid of the negative. And then tangent, you do kick it out in front. So sine and tangent, you bring that negative theta out in front. You'll see it's kind of nice. It's kind of like putting together a puzzle almost. So here we have to prove these trigonometric identities are equal to each other. So we have secant of theta equals cosecant of theta times tangent of theta. Now the nice thing is, you don't have to do these the exact same way that I do or the exact same way that your friend does, and it can still be right. But we need to pick a side to work on and kind of simplify it where we can to make it equal the other side. So to me, the right side looks a little more complex. So I'm going to work on the right side and see if I can make this turn into secant of theta using these properties here. So I see cosecant of theta. I know that cosecant is the reciprocal of sine. So let's start with that. So I'm going to make cosecant of theta 1 over sine of theta. Now this is being multiplied by tangent of theta. So I'm going to use this right here. This tan equals sine of theta over cosine of theta. Sine of theta over cosine of theta. Now remember, when you're multiplying fractions, you can simplify from any numerator and any denominator. So I see a sine of theta and a sine of theta. Those can cancel each other out, which just leaves us with 1 over cosine of theta. And 1 over cosine of theta, that's the same as secant, right? Those are reciprocal functions, which is what we needed it to be. We needed to get it to secant of theta. We did it. Look at that. We're already done with one of them. And that was fun. Don't deny it. That was fun. All right. Let's keep this party going. Whoa. Whoa. Here we go. Cosecant of negative theta equals negative cosecant of theta. Now you could turn this into sine and use sine's properties, but it follows the same properties as sine. So this is that negative angle identity. And sine is an odd, so we could just take that negative and bring it out in front. Now that seems lame, because then we're done, but it is what it is. So cosecant of negative theta, we're just going to move the negative out in front, negative cosecant theta, which happens to be what we need it to be. Woohoo! Yay! Now again, you could convert those both into sine, but it's just unnecessary steps. Like you can make this 1 over sine of negative theta, and then you kick the negative out in front, 1 over negative sine of theta, and then you just move the negative either to the numerator or out in front. You'd have to do the same thing on the right side, but we want to just work on one side. So that's where I think just go straight to the odd identity angle. Just kick that negative out in front for the cosecant, and you're gold, pony boy. Those ones are kind of lame. I'm not a fan of those. Those aren't even fun. So we have cosine squared theta times secant squared theta minus 1 equals sine squared theta. Whenever you see 1 plus something squared or 1 minus something squared, you're going to be looking at the Pythagorean identities. Now, it's not always going to be exactly in the form that it needs to be right away, and that's okay because you're such brilliant human beings that you could probably, finagle it a little bit. So if you look, we're looking for secant squared minus 1. If you look at this Pythagorean identity, it's green up here. It's 1 plus tangent squared theta equals secant squared theta. I could easily make that secant squared theta minus 1 by just subtracting 1 from both sides. So if I did that, that would be tan squared theta equals secant squared theta minus 1. So when I see secant squared theta minus 1 here, I can replace that with tan squared theta. It's like substitution when we did systems of equations, very similar. So we'll have cosine squared theta times tan squared theta. But again, we're trying to get it to sine squared theta. So let's see what else we can do. I know that tangent of theta is sine over cosine. So that means tangent squared theta would be sine squared over cosine squared. Let's see if that gets us anywhere. And then maybe we could write cosine squared theta as cosine squared theta over 1. And then if you look again, we're multiplying fractions, so we can cancel out a common numerator and denominator. We can get rid of cosine squared with cosine squared, which just leaves us with sine squared theta over 1, which is just sine squared theta. That's what we're going for. Wow. Okay. That was pretty fun. Huh? Let's keep that party going. Sine minus cosine over sine equals 1 minus cotangent. I don't know. Here's what we can try. When we had, we were doing our imaginary number system, if you had like 4 plus 6i over 8, you could split that into two fractions. They could both have the denominator of 8, because that'll simplify differently. Like 4 over 8 would be 1/2. 6i over 8 would be 3i over 4. So we could do that same thing here. We could split this into two different fractions, both with the denominator of sine. So we could say sine over sine minus, and then cosine over sine. All right. Now, sine of theta over sine of theta is just 1. Just like if it was 6 over 6, that would be 1. And then we have this cosine over sine. If you look at our tan and cotangent ratio identities, cosine over sine is equal to cotangent. No way. We're done. That's it. It's kind of sad that that one wrapped up that quickly, but that's the burden of being smart like you. No. Tan of theta equals secant divided by cosecant. It's probably going to be easier if we kind of write those separate, like next to each other. Secant divided by cosecant. Now, what do you know about secant? Well, I know it's the reciprocal of cosine. So we could say 1 over cosine. What do you know about cosecant? I know that's the reciprocal of sine. So we have 1 over cosine divided by 1 over sine. Now you know this. We're not babies. Except, oh, there is a baby there. Okay. All right. But when you're dividing fractions, remember the old keep, change, flip. You keep the first fraction, you change it to multiplication, and then you use the reciprocal of the second fraction. Now, you could cancel out the ones. Why would you? We could just go ahead and multiply. 1 times sine is sine of theta. Cosine of theta times 1 is cosine of theta. I recall seeing sine of theta over cosine of theta somewhere else. Oh, it's equal to tangent, which happens to be what we want it to be. Wow. This is a true delight. Please tell me there's another one, and please tell me it's not a negative angle identity. Ugh. It is. Unfortunately, it is. Sorry. I didn't know. I'm bummed out too, man. Remember, cotangent works the same as its reciprocal, tangent, which happens to be an odd identity, so the negative can just come out in front. So if we did that here, it'd be 1 plus negative cotangent of theta. And when you do 1 plus negative, that's the same as 1 minus. So then we'd be done. It would just be 1 minus cotangent of theta, which is what we needed. I think that's it. Let me double check. Ah, man, that's it for the notes. Until tomorrow. All right.